Hello everyone, this video is going to mainly focus on subplots and Matplotlib. Subplots are a great tool when you have visualization that you want to put across one another and create a visual that has multiple visuals inside it. And it can be a very useful data analytic tool to be able to put visuals next to another and be able to see those patterns that can be thrown out to the surface by visualizing in the correct way. So let's learn about subplots and see a couple of examples. So before we start learning what subplots are, we normally go ahead and do our importing the modules and clean the data, and then also add the rows to our air quality data. So subplots are basically sort of giving the programming language, sort of like telling the Matplotlib where you want to put your multiple plots. So it works like a grid and address. So you create a grid first, and then you start giving address. So for example, here, I want the three visuals we had, the line, the quadratic, and also the cubic. I want now to, instead of having them in the same plot, sort of like overlaying on top of one another, I want them to be in three plots next to one another. And that's how I go about this. I specify the grid. I'm saying I want one row and three columns. And now I want to work with the first cell. And then I want to work with the second cell, with the third cell. And once I run this, now I can see I have that grid-like visual that I'm working with the first cell. This is the current plot and the first cell. And then once I say subplot and then the second cell, my current figure changes to this one, and then so on and so forth. So that's how you go about creating subplots. So there is like a naming convention, or like indexing convention, that I will represent here. So what's happening here is really you have a grid, like I said, that you can have as many rows and columns as you want. So the example here I'm going to be using is going to be having 4 columns, 4 rows, and 5 columns. So when I say plt dot subplot, I have to introduce this by 4 and 5, and the last cell is going to be created or decided on based on what cell are you working on, what cell you are putting your current figure on. And if the naming convention is very simple, so the naming convention that start from the top right. So this is going to be 1. So once I say subplot 4, 5, 14, this is going to bring this cell, start working with whatever figure you have. It's going to like assume it's going to be in this cell. So that's a simple naming convention that the subplot has. So now that we have subplots here, some of these legends are not necessarily. So, I mean, this is just line. So we don't really need legends. How about we switch the legend to the title of the subplots? So that's what has happened here. So it's like much cleaner now. So now we want to put these subplots on top of one another. Instead of having them in one row, now I want to have 3 rows, 1 column. So I'm changing the definition of my grid basically here. So now that I do that, 3 and 1, now I can see them on top of one another. And that works completely fine. Let's do an example here. Do you remember on example 2 that we had the 30 days of January in the same slot, in the same plot with different colors. But now here, let's use a subplot to show that. So instead of doing one visual and like changing colors, I'm going to use subplot here. And I'm using 10 rows with 3 columns, so totally 30. And I'm using the index to, change the current figure that I'm working with from 1 all the way to 30. And since the subplot works from 1 to 1, 2, but this index works from 0, I'm adding +1 to it. And the rest of it is completely similar. So once I run this, now I get that every line in different plots. So I have day 1, day 2, day 4, all the way to day 30. Now I can see them stacked next to one another. Before we look at a couple of other examples of subplots, let's also learn about a new plot, scatter plots. Scatter plots are very useful visualizations, normally to see relationships between different variables and attributes. So for example, here I have created 2 random array, just like with 100 numbers, using scatterplot to plot them. So once I run this, I see that there is no relationship between random array 1 and random array 2. And that's a good thing because they're supposed to be random. We don't want them to have relationship with one another. If they had relationship, then the function random creation number would not be really functioning well. So that's, every time you run this, you're still going to get different numbers, but you will see that there is no relationship with one another. But let's contrast that with another example from our data. Let's now see if there is a relationship between NO and NOx. So I'm like getting all of those data, all of the NOs, by using an inline Boolean mask here. So I create that Boolean mask. I'm just saying I want to get all of the NOs, and then I'm going to get all of the NOx, and use a Boolean mask inline to filter out the data that I want. And then I scatterplot NO and NOx. And since they are highly correlated, I can also see that in the scatterplot they form almost a line, as if NO increases, NOx also increases. If NOx decreases, NO also decreases. So that's the relationship or the correlation NO and NOx have from in this data set. So other things we could be looking at here, we could be changing the marker and the color of these markers. So as you remember, these are named markers. So these are different markers that you have. You have a good variety of options here you could be using. And I'm just, asking you to, a little bit of practice, change these markers and these colors, and see that you could be changing them by just like saying what you want. So for example, I change this to P, and I change this to black, and now I get those pentagon marker. Or if I want a little bit like less pronounced, I can like have plus, and that's what I get. So in challenge 4, I want you to create basically this visual here. Pay attention. On each row and each column are representing one of the measurements in the air quality data. So as you can see, all of the diagonal figures are a complete line. And the reason is because this is basically showing the scatter plots of NO against NO. And that's supposed to be a line because they're the same variables. But as you move from the diagonal, you will start seeing the scatter plots of different attributes or different measurements, and you can see how they are shown here. So in this challenge, I want you to create this visualization by using subplots. So you have to work with the grid and then with the indexes and also create these subplots. So give this a chance to solve this on your own. After you've given it a fair chance, if you were not able to do this, continue watching on. I will give you some guidance to how to go about it. So one of the things that you probably tried was to do a nested loop, because you have species and you created your unique species and you want to go through all of the species. But the challenge here would be, because you have all of them, you would not be able to have this clear effect here that I have created, because they're going to be like repeated. So what's going to happen, it's going to be challenging to really create that grid and choose the eyes to find the right scatter plots. But this is going to be the skeleton of your code. So use this skeleton to still push yourself to be able to finish this. So one of the things you probably have tried is to sort of work with these I and II to create a third index to be able to create this. While finally you may have been able to do that, but the better way to go about this is to start using another function. It's called subplot to grid. So basically you specify your grid and you say what part of the grid you want that plot to go. And with this, you can actually say those specific part of the grid that you want your plot to go and sit. And with this, you simply can plot everything that you were interested. This is going to be a fairly challenging assignment comparing to the previous assignments. This is going to be basically bringing a lot of different aspects of our course together for you to be able to basically create this visual here. I want you to create this visual. What this visual is, you're creating 35 line plots, 5 rows and 7 columns, and each row represent one of the air pollution. So you have NO, NO2, NOx, PM10, and PM2.5, and each column represent one day of the week. Basically, we want to have a visualization that shows the profile of air pollution behavior on each day throughout the year. So for us to be able to do that, we need to calculate the average of all of the NO days for Saturday. Calculate the average of all of the NO for Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday, and so on and so forth. So first of all, you need to go about that calculation, or like calculating the mean, and then have a way to collect all those numbers, which are 24 numbers, to put them in the visualization, and then use a subplot to put that visual in where it's supposed to go. So it's a combination of Boolean mask, looping, calculation, maybe if you want group by, and then also subplot and visualization.